Hello and welcome to Nodes and Wires, where I'm talking to various guests who regularly respond to today's aspects of music technology in an attempt to map the current electronic music network. And today I'm going to chat with George Hearn, engineer, synthesist, instrument designer, and founder of the Bristol-based company UDO Audio, who introduced their first product, the hybrid hardware synthesizer Super 6, at last year's Super Booth. Hello, George. How are you?
Hi, Mike. Yes, very good. Thanks. Very good. It's nice and sunny here in Bristol, as you can see. I don't know whether the listeners have got a video as well, but yeah, I'm okay. Tired, but excited. We're on the final miles of getting our product out now, so it's obviously a busy time. But I'm well, thank you. Better to be talking to you.
First of all, I wanted to start off by congratulating you on all the positive feedback you've received so far after introducing the Super 6 to a wider audience. And before we carry on talking about what you're working on right now and the future, I'd like to take a step back and ask you how it all started. So, in last summer's interview with the Music Tech magazine, you mentioned that you've been building synths since you were 18. But before you eventually started with UDO, you pursued a career in electronics manufacturing along different industries. Correct me if I'm wrong, but if I do remember correctly, the automotive and aircraft industries were amongst those.
Yes.
First things first, though, how did it all start? How and when did you become involved in music or started being interested in music?
Well, I think my sort of music as a listener and like a consumer of music, and my interest of music developed like for most people, I guess, um when I was old enough, I think, to sort of go and buy a record. It was actually a record. It was actually a 45. I think the first thing I bought was from Woolworths, which was a shop that doesn't exist anymore in the UK. I think it was one of the last days of probably one of the last points you could actually buy vinyl before it resurged in the kind of high street shop, because my parents had a one of these like music systems. I don't know if you know the ones I'm describing. They have like a cassette player, and then they have the record player, and then they have the tuner bar, usually with the little orange lamp which you roll the pointer along the front, and they also include the amplifier, and you just connect some speakers. I think they were called music centers. So my parents had one of those. And then, yeah, my sort of interest in music grew while I was at school. But in music production, I studied music at school, and I got really excited about music production really when, what was it? There was a piece of software on the computers which were BBC Micros. It was either a BBC Micro or it was an Acorn. Maybe, like, for listeners outside of the UK, they won't remember BBC Micros and Acorns, but they were the first computers we learnt on. And there was a piece of software called Tracker, which was a really, really basic kind of MIDI sequencer, but it had a sort of like, it could make sounds as well. So I think it was contemporary with the Commodore 64 and the Amiga and the Atari ST, all around about that same time. And so I got interested in music production then. And when my music teacher brought in a synthesizer off curriculum, he brought a synthesizer in. I think it was a Roland SH. I couldn't say which one, but I seem to remember very vividly those spun lever toggle switches, same as we've used on the Super 6. I remember thinking then when he brought this thing in, it's like, I don't know what that is, but I want one. I don't know what it's for. I've never seen one before, but it looks great. Whatever it is, I want a part of that. And so I kind of got interested in synthesizers then, and I guess it all started with a band called Add N to X. And they are I think they're a British band. Anne Shenton, Barry Gregor, and someone else. And they make like real, like, it's like acoustic drums and synthesizers, like kind of really uh, loose, rocky, analogy kind of electronic music. Really love it, and it just got me well into music and synthesis. The cover to the album "On the Wires of Our Nerves," where there's a Moog Rogue, Moog Rogue. It has to be Moog Rogue if it's a Rogue, but Moog Rogue sounds silly, but being pulled out of somebody's chest. And when I saw that, I just thought that's like grim and fascinating, and it was like, yeah, I think ever since then I was into synthesizers.
You now already hinted at some cultural background. You and your company are currently located in Bristol. Did you also grow up in that area?
No, I grew up in a town called Southampton, which is on the south coast, and my mother's Norwegian and my dad's a Londoner, and I now have lived 20 years in Bristol. So I kind of, somebody says, "Where you from?" Um, I think I say I'm from Bristol now. But yeah, I grew up in Southampton.
I was asking because Bristol is quite a significant spot in the music landscape of the UK, particularly known for being a melting pot for all kinds of styles.
Yeah, 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 for sure. I think that's one of the reasons that drew me here.
Does the now existing local tie affect you musically?
It's a good question. Um, I guess it probably does. I mean, I guess like Bristol has got quite a big association with kind of bass music, and kind of drum and bass and trip hop and kind of well, actually all different genres, but certainly kind of being in Bristol, I guess, and producing an electronic musical instrument are probably quite, yeah, they're probably quite linked, aren't they? I'm surrounded by a culture of there's lots of music going on. I know a number of musicians who, and some, people who've sort of put Bristol on the map, and I guess that's very much a part of it.
And what triggered your interest in music technology and designing instruments?
Well, there's a shop here we have. Actually, there's a shop here we don't have anymore. Um, called Maplin, and they used to sell like electronicsy parts and components, and they used to sell kits. And when I was at school, I think one of my Christmas presents was a Maplin 20-in-1 electronics kit. And this is like you get a bunch of components and you get some little springs that you pull over the springs and you put the component wires in the little springs and you make circuits. And I think that in combination with being interested in taking things apart and being interested in the sort of early days of sort of home computing. We had a Spectrum ZX at one point. I don't know if listeners can remember those, but they were great. I guess that all just kind of came together, and so then I got interested in electronics as a sort of hobbyist um, when I was about 16, and then I think being really into my music then and my kind of my raving and like my kind of electronic music artists being interested in like music production, but not really. Well, actually, I got well into music production by the time I was 16. And so being into music production, having a hobby interest in electronics, being fascinated by synthesizers, I just put it together then. But it was, it would be 20 years before UDO would happen after that. But I think that entire 20-year period, um, I wanted it to happen. I could see it happening sometime in the future.
So what happened in the meantime?
Oh, John Lennon that said, "Life is what happens when you're busy making other plans." Um, yeah, well, like I went and I studied electronics at university. Well, actually, let's rewind a little bit. I studied maths, physics, and electronics at A-level college, like sixth form college in the UK. I got thrown out, um, and then I worked for a while, various really shitty jobs. I worked on a landfill site, which is obviously where they tip rubbish. I worked at the docks, where they were importing vehicles. I worked in industrial cleaning for a while, and then I went back to sixth form college, studied the same again, and then I went to university to study electronics. Um, at the time, I was more into gigging and writing music and partying, and consequently, they also threw me out. But so that didn't last very long. And so then I spent about 3 years in the wilderness, sort of living in Bristol, kind of like just working in nightclubs and cafes and stuff for a while, and then, but still really wanting to do the synthesizer thing. Um, so I set myself up I got like a a workshop lab, and it was like horrendous. The roof had leaks in it. It was cold. It was dreadful. Um, but then eventually I got a building in an art studios building, and so it's like it was painters, sculptors, um, artists of all kinds, and then me, the weird guy doing electronics, like totally out of place. But I think it was part of the identity of the company that would later come. Um, but I think I realized quite quickly that I didn't know enough. And so I went back to university again. I reapplied, and I then did it, and I studied, and I graduated. And I guess that's when um, I had a career in electronics and engineering and technology development. Um, I think to begin with, I really wanted to make musical instruments and design music technology. But, you know, I think for many people, myself obviously included, you have a plan, you have an idea, you have a dream, but life comes and gets in the way, and it like takes you on another journey, and you're not necessarily the driver in that journey, rather a passenger, or a sort of victim's too strong a word, but you are um, just part of the events that happen, rather than the, the the driver of those events. And so I had I had a sort of 12, 13 years of doing um, technology development. First well, I worked for a year for the Renault Formula One team, which was a really good job. Um, but that's actually where I cut my teeth as an engineer. That's where I really learned how to do um, engineering. And it wasn't so I'd graduated by this point. I had my hobbyist experience, but now I was in a proper environment. I was really doing engineering development in a place where these fantastic vehicles were being made, and everything is made under one roof. So I got exposed to all aspects of machining, forming, fabricating, welding, electronics, programming, circuit design, building, rework, how to make things for reliable environments. So that I think is where I really learn. But I cut a long story short, I'm not really that into Formula One cars, or cars in general. And I wasn't a fan of the culture that I was a part of, and um, much to the dismay, probably of my parents, I um, didn't manage to hold that job down. So I actually left, and then I worked for another firm. Well, I spent a little bit of time working for the land speed record attempt, the Bloodhound project. They're trying to make a 1,000 mile per hour car. Um, but after getting involved for that a little while, I didn't actually get on that well with the engineering manager. We didn't see eye to eye. And so that didn't last very long either. Um, so it's quite interesting how now when I look back on it, I had quite a series of false starts. Um, but then I did some successful work over a number of years for a company. Um, and then eventually I went, sort of became a consultant, and then later set up a professional lab where I had a small team of consultants and we ran a consultancy business. And throughout that time, I worked for Bombardier Aerospace, who are the Canadian engineering company. Started off they invented the Ski-Doo, but now they make planes and trains and all sorts of things. I did a little bit of work for the Met Office, which is the weather organisation in the UK, and for British Airways Avionics. They're an airline here. Um, but always in the background, I was always really interested in music and music technology. And so I was making all these hobby synthesizers, and some of them were quite elaborate machines. Um, and I guess eventually I met I met Paul. Well, I knew Paula Maddox, but I met Paula Maddox and Philip Taysom when they were just starting Modal, and so I got involved with them. And I was already making these chip modules with Hearn Morley. Um, so back in the day when Curtis and SSM chips weren't available at all, these were actually a sort of a way you could make a reliable analog polyphonic synthesizer. Um, and now, there's lots of chips and there's more instruments around, but for a while there really wasn't anything available like that. And so it was one of the hurdles that I overcame to make a polyphonic analog synthesizer myself without those chips. Sorry, without conventional ICs. But then I thought, oh well, I'm not ready to sell a synthesizer, but uh, I can sell these chips. So I was doing that in the background, and I sold a license deal to Modal for some technology that became the 008, and I helped them develop all of the sound making, so the analog and the sound making digital hardware inside the 008, and they did the chassis and user interface. Um, and then in the background, I made another polysynth called Artisan. Um, and I guess it's sort of, I had a bit of a lull for a bit after that. The experience with Modal was good, taught me a lot. But I think it wasn't something I wanted to be involved in longer term. And so I think I got back to doing engineering again until one day I woke up in the morning, and I don't know, maybe the listeners have experienced something like this, but anyone who dedicates themselves passionately to something, one of the most frightening things to ever happen is you wake up one morning and it's evaporated and you can't do it anymore and it's gone. And I had a morning where I just was like, what the work that I was doing, I could not do it anymore. I just didn't care. A seed of doubt crept into my mind that said, is this all worth it? And the conclusion I came to was no. Um, so what happened in that case was that I I basically found myself sat there. I had a really nice laboratory. I had all of the engineering tools. I had all of the experience of kind of 15 years in technology production and manufacture in various industries. I had the experience with Modal. I had some contacts. I'd made several synthesizers, some analog polysynthesizers. Um, so at that point, I just thought, well, you might as well make a run for it now because um, when else are you going to do it? So it was probably a moment of insanity, and I'm still questioning whether it's the right thing to do. Maybe we speak again. Maybe we do another interview in a few years' time, and we'll see.
You covered a lot of ground already. What kind of synthesizers have you been involved in? The 008 by Model Electronics and the Artisan, you said?
Yeah, so I made a analog monosynth when I was a teenager. Um, I named it the Electro Ninja, and it used Curtis VCOs and solid state music technology or solid state micro technology, 2040 filters, 2060 VCAs, 2050 um, ADSRs. And then I made a synthesizer called Domino, which was a discrete analog polyphonic 8 voice synthesizer, and then Artisan, which was another discrete um, polyphonic 8 voice synthesizer. Um, so actually, the UDO Super 6 is my fourth go at making a analog polyphonic synthesizer, if you count the Modal 008 as one of them.
Did the engineering experience you gained in other industries inform your approach towards designing synthesizers? And if so, how?
That's a really interesting question. Um, I think the answer is yes, absolutely. Um, but oddly, I think it's in more subtle ways than might immediately be apparent. When you look at the synthesizer and when you touch the synthesizer, you feel the knobs, you press the switches, you move the controls. Um, but really, I guess it's that side of it that's come from um, playing musical instruments and liking musical instruments and having a sense of what a musical instrument should feel like. The borrowed experience from my other industries, from my work with Formula One, from my work in industrial controls, actually has been a major part of it. And aerospace has possibly shaped the front panel look somehow. I think it's really the construction and how the thing's made inside, how the processes are developed, how the company processes are developed, how the manufacturing documentation is developed, and how the quality system and how the organization is developed. I think these things you can't um, you can't see necessarily, but I'm hoping that what will happen is that they'll become apparent in many years to come. So, for example, our choice of how we construct the internal construction, the choice of cables, the choice of components, the choice of system architecture, um, with the knowledge of, okay, well, this might be used in this environment, this might be used in this environment, you know, that I sort of might know that some particular type of crimping technology is vulnerable under this kind of situation. And so I think the engineering experience that I've had has embedded itself more in the construction of the instrument internally and its sort of engineering and the operation of the production of the instrument in terms of process, build procedures, and manufacturing instructions, rather than its visual and tactile qualities, which really just come from my personal sense of a musical instrument should feel like X. You know, I we all have, maybe we don't all have, but maybe the people that are interested enough to listen to us have a love of certain vintage pieces of equipment. And quite often, these vintage pieces of equipment might be a bit flaky, they might be a bit unreliable, they might be limited. Um, but that solidity and confidence that you get when you turn big clunky click switches, or you move nice smooth pots, or you push nice faders, or you have a nice mechanical weight to things, it gives you confidence. And I think that I think that is really behind my choice of design. This thing's not a computer, it's a musical instrument. You need to feel confident that it's gonna behave, it's gonna last. And I guess something which has sort of embedded itself in me. I've worked a lot in medical devices as well. I mean, we haven't really talked about that, but that's like that was probably the bulk of my work over the last 5 years. Um, is that really something has to has to really perform its function for, well, let's say you work for a medical or surgical device tool. It has a lifetime. You have to make a good rationale for its operating lifetime, and you have to provide a verification, and then you have to provide validation, and a validation that it will be good for its lifetime. These lifetimes might be like, I don't know, 4 years of operation, 5 hours per day. A musical instrument's a bit different because I think a well-designed musical instrument is a timeless thing. And so we've had to design something which, even when it's dented and damaged and is old, and maybe you've bent one of the sliders or you've lost a couple of caps, that it still looks okay, it feels okay. And there are some materials and processes that don't age very well. So we've tried to use things that do. We've tried to make the inside very serviceable, and we tried to make the technology, like, for example, the sliders, the switches, and the pots of the main synthesizer section are the same design, and in fact are almost identical to the ones used on a Roland Jupiter 8 back in 1984. Um, there's a very good chance that these same designs will still be being made in another 20 years. So we've tried to make the thing serviceable, um, but also, like, yeah, tried to make it so that in kind of in a bunch of time when it's all scratched and dented because you did that gig in that pub that time and you whacked it on the door when you went in, um, but it still has an honest quality to it, and that it can stand up in a secondhand music store next to some um, relict guitars and can look good. And I think that's really, really what I wanted from the design. And when I spoke to Axel, I was really, really clear about this, that um, we needed to make the design like this. And there were a few things then that precluded us from using, basically.
Talking about the instrument's actual design, you once said that with the Super 6, it was your goal to achieve depth with simplicity, and that both concepts shouldn't be at odds with each other, which in turn emphasizes a focus on performance and an immediacy that prevents the user from getting lost in too many details. Notably, the Super 6 doesn't feature a screen or display, and its overall appearance seems to echo particularly the Roland designs of the late 1970s and early 1980s. At the same time, the instrument utilizes current technological advancements, such as an FPGA. But before we get into the details, could you tell us how you start or approach the design process? I mean, when did you actually start working on the design of the Super 6?
It's a bit like, you know, saying to when did you get together with your partner? Was it when you meet, or when did you start? When did you become boyfriend and girlfriend? I guess we met um, years and years and years ago. It just didn't become a synthesizer till many, many, many years later. But really, it took about a year and a half in development. I think we moved into the lab proper in August of 2018, and by Superbooth 2019, we were demonstrating the product, um, and then yeah, here we are in 2020. So it the idea started in notebooks. I think I decided that I'm going to do another creative project, and I'm going to start, and we're going to do this. And so it meant filling up lots and lots and lots of A4 notebooks. I was asking people to talk about things that they liked, and I took my notebooks with me everywhere. Took them to cafes, I took them to my friend's house, I took them on holiday, took them into work. And every time somebody said something interesting when we had a conversation about what they loved about instruments and what they loved about music technology, I'd write it down. And so it was full of abstract things, abstract bits of text. And it spent a long time in this genesis phase before it actually came right back round the circle. I had all sorts of these ideas to do all sorts of different other things. I just said, I want to do a creative project in music technology. I didn't know what it was. And so I went round and round and round and round until I actually came back to the conclusion. It's like, no, actually, I'm going to stick to what made me start all of this, and I'm going to do a sort of an analog polysynthesizer. And I think it was really Paula Maddox who got me excited about FPGAs, when she just sort of mentioned them and what they can do. And then I sort of went away and I looked at it and I was like, oh, wow. Oh, yeah, that solves that problem that I've been struggling with for ages. That solves that problem. Um, and then I guess the decision to make a polysynthesizer started there. But again, it all was very vague. I was just more concerned with feel, you know, what does this thing feel like? What emotions does it invoke? Like what does the sound like? Is the sound bulbous? Is it soft? Is it aggressive? Is it warm? Is it, it was more thinking all on these things until eventually it was like, oh wow, okay, no, it's the Super 6. This is a polyphonic, hybrid, immediate, playable, solidly built musical instrument that's like both nostalgic and futuristic all together, sort of eventually just popped out the top from it. It almost was like an output from a process rather than we're going to build that to begin with, if that made sense.
Are you designing more from the inside out or more from the outside in? In other words, what comes first for you, the internally used technology or the specifications or the user interface, everything that meets the eye or the ear, maybe?
Do you know what, Mike? I don't know. Yeah, I don't know how that happened because they're almost like parallel streams. So while you're thinking about the top level about what it feels and looks like, and then that's developing, you're also thinking about how you're going to implement your vision through technology. And then sometimes the technology affects this one, and then sometimes this one affects what technology you put in. But we did a long process of like laying out different switches and combinations and features, and eventually we settled on what we came up with, which was a combination of switches, sliders, um, rotary switches, rotary pots, which is this lovely kind of interface mechanical combination that Roland used to use. Interestingly, before this Jupiter 6, so our synth has much more in common with the interfaces of the old Roland SH series and the Jupiter 8 than it does the sort of Jupiter 6 and Junos, which is it's more often compared to. But it's like what we did is we thought, well, that's a really nice way of doing things. I love the combination of knobs and sliders and switches. It's all visual, really nice. But if you look closely at Super 6, every little switch has a little sort of secondary function, and there's a little something which you can go a little bit further or change things around. And so there was a bit of technology steering the design and then the design steering the technology. But I think we managed to resist the temptation to throw everything in there, because when you do that, just because you can doesn't mean you should. In my estimation, and actually having an instrument which is flexible but can remain immediate, getting that balance is like a tightrope. And all the time we've tried really hard to do that because, of course, God, we've got loads of power in there. Um, Maybe this engine, who knows? I mean, who knows what updates we could make to this thing later on with all that sort of spare capacity that's embedded inside it. Um, it's not like sort of the early days of digital synths where um, you were using every drop of DSP power. Now we've got like half of it sat there doing nothing. Um, Call it not a can of worms, but a can of opportunity.
Beyond like-minded tech wizards, are there any artists you regularly meet or who you would even consult for suggestions or feedback?
Yeah, indeed. I mean, I'm sort of embedded in a community of musicians here. And, I think myself, maybe less so, but my two colleagues, Will and Anthony, are both producing musicians. We have a network of people in Bristol that we speak to regularly. We now have instruments out with testers. Some of them are themselves professional musicians or sound designers. Um, I think the entire journey has been, well, everyone involved is an artist in one shape or form. Everyone is like a music producer, even if their day job might be engineering or graphic design or development or something like that. So I think that's very much, this is an indie instrument, isn't it? That's been produced exactly out of that sphere. Um, do we have sort of high profile consultant um, musicians to inform it? Not really. But we do have a network of people that is growing all the time who are helping to feed back on this product basically. And we're trying ways to sort of organize this feedback the best we can. Um, I think anyone who's made something which is so subjective as a musical instrument will understand if you ask people 12 ask 12 people the same question, you get 12 different answers.
You already brought him up. You got one of the really few really well-known synthesizer designers on board, namely Axel Hartmann, who has been responsible for so many iconic instrument designs, including products by Waldorf, Axis, Arturia, Alesis, Schmidt, and Moog. Out of curiosity, was it his or your choice to hark back to a user interface that evokes the look of older Roland machines?
It was ours. I think we came to him with a 3D model and a setup, which was pretty much every control where it was. What Axel did is he made it a modern instrument with a modern construction, and he designed all of the look and feel. But we collaborated on the graphics. Um, but all of the chassis and how the chassis goes together was a combination of work from Axel and a guy called Frank Ruffel at HMT Ruffel, who came up with it. Um, I think for us, I think it's just fair to say, let's not beat about the bush. We're just Roland fans. We're like classic Roland fans. And, what I wanted to make was something that is not a pastiche and is not a clone, but captures some of that magic. There's a bit of magic in those old synths. I can't explain, I couldn't put my finger on what it is, but it's a bit of magic. And you sit in front of the synthesizer and you go, oh, yeah, I know what that is. I know what it is. I can see what that is. That's one of those, isn't it? It's a synthesizer. And that classic appeal. Um, yeah, I mean, I just love those switches. Those toggle switches are amazing. I love using them, and the kind of the combinations of sliders and the sort of combination of the different types of elements next to each other in these little clusters just works so well. And you know, I thought, well, yeah, let's. There are lots of clones about reproductions of instruments. The UDO Super 6 is not a clone of anything, but it's inspired by lots of things. Because we've got like buttons that are a bit like an Elka Synthex or Prophet 5, for example. We've got like the synth area layouts very similar to, yeah, Roland Jupiter 8. We've got little elements from all sorts of things inside it and outside it. So Yeah, Axel gave us some concepts. It's funny. There's a concept A, and we called it Model 1 and Model 2. We had a Model 1, which was the Super 6 that never was, that Axel came up with, which might be fun to share sometime, or maybe even to make a sort of limited run of, which was a sort of very a kind of modernist version. But that's actually my choice to say no. We're gonna, out of the different styles, I'd like to go with the sort of, the raised panel classic wedge. Um, and I like what he came up with in the end. I really do. He helped make our ideas and my sort of engineering of the internals. He made this into a proper consumer product, with the help of the manufacturing company as well.
How did the collaboration come about? The collaboration with Axel Hartmann.
I sent him a message on LinkedIn, and
That's all.
yeah, you got to start somewhere.
Yeah.
No, and I told him about the 008, and I told him what we're doing, and we made a brief for him, and I think it's quite interesting because although we're a small company and we're obviously got small resources. What's quite good is that because I've done so many technology development projects and products before, I've gone through a lot of this stuff, but just not in this industry. And I find the music industry is quite a funny industry. It's like you go in somewhere like with an audit form looking to inspect their quality system to some ISO standard, and you just get laughed out of the place. Contracts seem to be like mates agreements based around shaking hands. So I've had to readjust how I do things. But we provided a brief to Axel Hartmann, which I prepared as well as I possibly could. And we provided him basic 3D models, a brief, a mood board, and he said to us it was one of the best briefs he'd ever received from anyone because it had really communicated what we wanted. And so we communicated not just this is the controls we want, this is how they want to look like, but how does it feel? You know, what is the ethos behind it? Why are we doing this? What would people say about it? What do we want it to invoke? And he took it and he ran with it, and it was really, really good. So providing the proper brief to Axel really helped. And the same goes for manufacturing. For the manufacture of the synth, we've meticulously prepared production instructions and procedures for every aspect of its construction to a level which is more akin to medical device construction, not musical instrument construction. And so actually, to me, it's felt like like a sort of lesser version of a normal day job. But the manufacturers came back and said, "These are, these are the best instructions we've ever received. Nobody else seems to bother to this level, and it's really disappointing. But we're very happy to receive these instructions." So I think that like really respecting what these people collaborators like Axel Hartmann and others, respecting what they do and giving them the inputs that they need to do their job in the best way possible has really helped us as a small company to at least kind of, you know, get get sort of get good build up a good relationship with sort of like well-known designers like like Axel and Designbox. And really, it's really from me. And I think about it as that my times as a consultant, if somebody comes to me with a very well-defined idea, with a very clear brief and a very realistic set of expectations, I was immediately respectful of that and thought, okay, well, yeah, this is good. This is excellent. Now I can go away and take these requirements and specifications and do my part of the job. And I think sort of working with people on that basis, um, people you generally tend to, what's the word? It's well received, basically. So yeah, I just messaged him on LinkedIn, chatted it. It helped that I've been involved in the 008, and he's like, oh yeah, I'm not familiar with the instrument, and yeah, provided a brief, and then we got a quotation, which we haggled over for a little while, and off we went, basically. And I'm very pleased with the results.
Beyond the unique design of the Super 6, one of its unique selling points is actually that it is a binaural synth. There has been a lot of discussion about this terminology online. Can you, once and for all, explain what makes this concept unique and how it differs from just stereo?
Binaural, in its, if you were to just dissolve the word, means of two ears, with two ears. So a conventional synthesizer tends to have a mono voice, which is then panned left and right, um, which then possibly goes through some stereo effects processing. The Super 6, when it's in its binaural mode, has uh, two complete synthesizer voices. So that's all of the oscillators, the analog filters, the modulators, um, are separate for each ear. Now, it's not the same as just playing a unison of two notes, hard panned left and right, because actually we carefully lock the phases of the oscillators and we do some control of the partials of the oscillators. And similarly, the modulators can be locked together, but with a split phase. And so the result that you end up getting, especially when you take care of when you take into account the sort of slight variations of the analog filter from left to right, is a sound that has a real sense of spatial positioning. So in some senses, is it just stereo? Oh yeah, but in a way that is not the same as just putting a mono synthesizer voice through a panning or some sort of chorus. It is actually intrinsically a stereo binaural synthesizer. So the stereo aspects are actually part of the whole construction. And the linked modulation of the left and right channels is done in such a way to sort of promote a sense of kind of spatial positioning and movement. Um, I think when you have a little play around on the instrument, it becomes immediately apparent. When you put it in binaural mode, you perhaps put the super wave control on, turn the sort of detune fader down to some low level, you can really feel the sound doing a kind of gradual spatial movement, and it sounds great in headphones.
And how did this concept come about?
I guess it's like it sort of just occurred to me, really, that the problem is with electronic sounds is when you try and sit them in a mix, particularly with other acoustic instruments, they tend to sound a bit flat, like they're kind of they don't quite um, gel together that well, and it's almost like there's a lack of sort of sense of space behind them. Obviously, really good reverbs, bit of sort of selective stereo EQing and stuff like that tends to help. But I wanted to make an instrument which was right out the box when you plug it into some speakers, a nice full wide sound that could sit alongside other instruments. And sort of be less kind of placed in a stereo sphere. And then when I coupled that with, quite often in electronics, parts tend to be dual or quad. So looking at it, I figured out I could get two analog voices on one of these voice cards, and I did everything in pairs. So it's like a pair of this, a pair of that. There's like 4 VCAs on a chip, so that's two pairs of mixers. Um, the filters, obviously, it's just two complete separate filters, but the VCAs are done in pairs. Everything's sort of making the most economical use of those electronic parts as well. So I guess it just sort of came from there, really, that we wanted something that had a little sonic advantage amongst other instruments, but could then not disadvantage itself by halving the polyphony, such we had a mode to take it out of binaural and into full 12 voice.
Could you also explain what makes the Super 6 super? I mean, that is what ingredient in the synth's voice architecture that term refers to.
Ah, it's just great, Mike. Just kidding. No. Um, well, Well, firstly, it's a bit of fun, isn't it? It's one of the brief for Axel was that, look, this is like a kind of um, a fun synthesizer. It doesn't take itself too seriously. It's almost like an over the top comic book version of a synthesizer. It's a little bit it's a little bit cheeky. It's the Super 6. But in terms of like technology, um the key thing here is that oscillator 1 is actually 7 oscillators. So there's 7 free running oscillator cores, and each one of those oscillator, sort of what we call them, a main oscillator and sister oscillators. The sister oscillators are phase controlled in your left and right ears, which gives you that sort of nice spatial positioning sense. And in that sense, it's like the classic super saw sound, but every wave we have is a super wave. So every oscillator waveform is actually can be duplicated 7 times and then detuned spread, and then the binaural processor gives you this big wide stereo thing. So I guess I call them super oscillators, and the same applies when you use the waveforms from the sort of digital waveforms. All of these digital waveforms can also be um, split and spread in this super mode, where it actually makes 7 copies of the initial waveform, and they're actually full independent free running oscillator cores. And I guess that's the technology that gives it the Super 6. But also, it's just a nice name. I like it. It's fun. Um, Synthesizers like to have numbers, don't they, on them as well? Old synthesizers, anyway.
Let's briefly talk about one of the analog components of the Super 6, namely its filter, which is available for the left and right audio channels of the Super 6. With that many current filter options at hand, what made you decide for the updated version of the SSM 2044 filter, the SSI 2144, designed and manufactured by Sound Semiconductor, a veteran team of audio technicians that also includes a certain Dave Rossum?
Well, I think you touched on it there. It's the veteran team aspect's pretty important, isn't it? So, all we might be new, but this whole synthesizer project has been contributed to by veteran teams of people: Axel Hartmann, HMT Rufel, Sound Semiconductor. These people are experts, and they're steeped in the history of synthesizer production. Um, what And also Dan Parks, who's the guy I deal with at Sound Semiconductor, is such a nice bloke. He's like a really, really nice guy, and he's a real pleasure to deal with. And his enthusiasm and his professionalism is just quite infectious. And so, yes, there are other things on the market, but when I spoke to Dan, and bear in mind, it's an important decision. He for some reason decides he can't sell us any chips. We can't make any synthesizers. So you're kind of building a relationship with somebody. And so obviously we'd get around it, we'd make a synth with a different filter, but we don't want to have to do that unless we have to. And I also think that it's a classic synthesizer filter. It's a ladder filter, which means it adds quite a lot of coloration to the sound. It's got quite a soft bulbous tone, and I thought that would go quite nicely with the digital oscillators, which can be a bit more sort of sharp and precise. And so the combination of the two together, I thought, would be quite nice. And also, it's a it's a different sound to many of, like, say, for example, classic Roland synths used OTA filters, sequential synthesizers, OTA filters. The Moog, memory Moog, used ladder filters, as did the 002 and 008. And there's just not that many polysynth ladder filter types, so I thought it would give it a bit of something. And also the chips are available. They were small. I trusted the people. I trusted the company. And I tried some out, and I was like, oh yeah, that's nice. And Yeah, we sort of went with that. I think if I do something again in the future, I'll probably keep using this company's output for sure. I'm a big fan of Sound Semiconductor.
Can you tell us what made you decide for using FPGA technology and what are the general advantages of using an FPGA as opposed to, for example, a DSP-based engine?
There are two main advantages, and there are two very serious disadvantages. The disadvantages don't come across to the user necessarily. The disadvantages come across to the manufacturer, but the advantages are all benefited by the user. So I think the key thing is that an FPGA can run at 1,000 times higher processing rate than any DSP, really. Um, I say 1,000 times, but generally speaking, if your peak audio rates are kind of, I don't know, 100 kilohertz or 96 kilohertz or whatever, or even double that, an FPGA can run at, a megahertz, 2 megahertz, 20 megahertz, 50 megahertz, 200 megahertz. Now, these are actually sample rates. So, although you might say, okay, well, my DSP runs at a gigahertz, well, that's running instructions consecutively, whereas an FPGA can run at 200 megahertz, but it can process everything in parallel. So that all of your oscillators, envelopes, LFOs, sources, modulators can all be processed all at the same time, all simultaneously. And it's that parallel processing power. So there's that part of it, but also from a musical sense, an FPGA lets you assemble things like you're assembling circuits. So the creative process is different. The way you think about circuits is different. Um, the way they interact is different. I can put a block down that might be a delay block, and it will act on its own independent of everything else. I don't need to think necessarily too much about its interaction with the rest of the circuit. And I can make these little functional blocks. I can wire up these functional blocks. And so an FPGA is like assembling a digital circuit. So what you end up with in the end is something that more resembles the assemblance of an early digital synthesizer, which was made like, say, a PPG wave or something, that was made with logic chips and address counters. And that's what you end up with in an FPGA. You end up assembling logic chips, address counters, memories, and you wire up these with delays and so on and so forth to wire up these digital circuits. And then you power up these digital circuits and off they go. And so the process being different, and the fact that you've got this parallel processing, this huge sample rate, which allows you to get away with lots in terms of not necessarily needing to band limit a lot of stuff and being able to compute really fast envelopes and to have audio rate modulations that sound really good. That's great. But also the creative process is different. How you think about the circuits is different, and it results in something that sounds different. There's a lot of debate. I can almost hear the internet scream at me, "Oh, the same algorithm on a DSP is going to sound the same as an FPGA." Well, it's a bit like that, but if you kind of think about art and creative processes, actually choosing your methods to come to the end result is a really important part. Artists will tell you all about that. The way you come, the method you choose to come to the result is important in the end result. So they're the key advantages is the way that you can assemble these circuits, the parallel processing power and the high sample rates. So that allows us to do, oscillator 1 is 7 oscillators, oscillator 2 is 1 oscillator. So there's 12 of those, 12 voices of 7, 8. Says 50, oh god, sorry, 96 oscillators, for example, plus all the LFOs and all of the processing. It's masses of processing, and it's all done at multi-megahertz rates. You couldn't do it on a DSP, a sequential processor. Yeah, you could do the same sort of things, but not to the same sample rates. And so, why would you buy hardware? Well, a computer can't do analog, and it can't do those same FPGA type high sample rate processing. It just can't do it. So this synthesizer, the Super 6, does the things that a computer can't do. It's almost like, to me, the analog and the 50 megasample per second multi-DAC FPGA are what kind of give it its sound, and they're things you can't get from a computer. So you couple that with, okay, well, why else would you not use a computer? Well, this lovely big interface and this solidity and the feeling of all these controls. So we tried to make it not a computer. So the FPGA helps with that. The key disadvantages are programming an FPGA is like banging your head repeatedly against a brick wall whilst throwing away £10 notes, €10 notes. It's horrendously slow development cycle, horrendously slow, but painfully slow. And the devices are extraordinarily expensive, much more expensive than really fast top end DSPs. I mean, the FPGA costs nearly 10% of the overall cost of the instrument. When you think about that, that is insane for one device. So I'm hoping that in the future, FPGAs get cheaper, and then we can pass that on to the customer. But at the moment, they are esoteric, state-of-the-art devices, and they are expensive.
I was just thinking about something else which might be an obstacle. You hinted at that a little bit earlier when you said that the FPGA potential under the hood is almost left a bit unchallenged. That obviously opens the path to the question whether you would or could see yourself expanding any features. But can you do so without running the risk of hitting the featureitis curve?
I think there are a number of ways, and what we've tried to do with the Super 6 is we've tried to use technology under the hood in a kind of transparent way, such to kind of like use the technology to improve the user experience, really, rather than, oh, look at all this technology. It can do all of these things. Wow. It's almost like subtle, understated. Okay, well, this is like the technology's under the hood doing the business. So it might just be that the things we're able to add at a later date might actually be quite subtle. You know, they might be subtle things we're doing with the technology that just might help to improve the sound. You know, good example is we might double the pitch resolution, for example, that's used for all of the pitch computations. It's not going to have a major effect. All your patches will sound the same, but you just might get a little bit more smoothness. You see what I mean? We might change, we might increase some sample rates in X, Y, and Z places, or we might interpolate a bit with a more sophisticated algorithm with our waveforms, or these kind of things, these kind of subtleties that are using technology but are not necessarily adding features, but might be um, making improvements to the sound and feel and the experience of playing it. So I don't want to promise anything either.
Maybe I shouldn't ask the following question then, but you don't have to promise anything, and it's still early days. But you once hinted at the possibility of creating a whole range of super synthesizers and developing a complete ecosystem that would also include complementary editors and librarians. Are you still planning on doing that?
Our primary focus is to support the ecosystem of the Super 6, to support our customers, to support the people that have got involved with us, to support the people that have the instrument, and to work with sort of sound development and new sounds, new waveforms, code updates, which may include some additional features later on. I would love to look at the environment with the computer. Maybe we can work on some more integration utilities. I'm not going to promise exactly what they'll be, but certainly we have got plans to work on this kind of thing. So that's first focus, Super 6 customers. Moving on from there, I mean, we'd be daft, wouldn't we, if we just came and made one instrument? We're not going to make any money from this. But what we're hoping is that all of the learning and all of the technology and all of the plastics tooling and all of the supply chains and all of those tacit things that we've built up through this process, we're hoping that those will be what we're able to exploit later on, and to use that capture some of the good stuff about the Super 6 and embed it into some future products. I can't say what they'll be, but yeah, certainly we're working on them.
Your company is based in Bristol, while the hardware assembly is actually taking place in Germany. How many people are you currently working with, and what are their roles?
But it's kind of a sort of 21st century company. So we have a sort of split hybrid team of in-house and out-of-house people. We have myself, Anthony, and Will here in the office, sort of regular conventional staff. Me as director and chief engineer. Will as sort of marketing and artist outreach. Anthony as full-time developer. Um, we have in the outside teams, we collaborate. My brother, who's a part of the business, my brother is a graphic designer, so he's helped with all the graphics and the logos, the look of the synthesizer, all of the visual identity and branding with his company, Studio Foss. Obviously, we have Axel Hartmann's design team, which is all industrial design. Then we have the manufacturing partners in Germany, HMT Roofall, and of course the consultancy services that they provide. Then we have a network of supporters, beta testers, sound designers, um, people helping us develop demos and test the instrument. We have people like yourself, Mike, who have provided invaluable help with the amazing work you did on the manual. That's then gone through several more revisions, which now Anthony has taken on, and then Magnus has produced into a proper book. Um, then, of course, we have our manufacturers in the Far East that help us with the control elements that make the plastic parts of the synthesizer, so like slider caps, knobs, this kind of thing, and supply the specialist custom components, custom control element components. So it's like yeah, it's very much a sort of a small group of core people in here in our office, but a large international global network of experts, musicians, engineers, and designers, sort of that formed a consortium to make it happen. Um, and yeah, it's quite difficult. It's managed across umpteen different time zones and continents. But then again, why not? Our customers are based across the entire globe, and so this instrument is built from suppliers around the globe. Um, it's certainly not a UK thing or even a European thing. It's a truly global collaboration.
As of the past few years, the music industry has been going through some major shifts. More and more manufacturers are empowered through online business options and the direct interaction with customers. Old distribution models are slowly fading away, and some of the once mandatory events, like the NAMM show, are losing significance, at least with regard to being exclusive places for the announcement of new products. At the same time, other and more specialized events took a leap forward, like the Synthfest in the UK or Superbooth in Germany, or NobCon in the US. And how do you see the future when it comes to the interaction between manufacturers and customers or the rest of the world? What do you perceive as challenges and opportunities?
Well, I think there's a lot of focus on sort of, we're just going through it now, productivity tools and user experience design as almost its own whole discipline. So the way manufacturers engage with customers and the way product design and the experience map is drawn out for how a person interacts with a company and a product experience. This whole thing is shifting. You know, I don't watch an advert on TV and then walk down to my local dealer and ask about it. I probably watch it on YouTube, go to their website, read a review on a forum, see what people are saying, and then go from there. Um, this is changing. I think, the Super 6, we're using very conventional channels. So we are doing, the distribution, international dealership sales model. This was old school, you know, and because, there's more to this than just us. There's a whole ecosystem, there's a whole industry that exists and serves a good purpose and should be supported. And so we, I think the direct interaction with customers, we're going to have to get prepared to do a lot of that, to offer good support. And I think there are a lot of challenges with a small company with the immediately accessible world. So I think customers, rightly so, you spend a lot of money, but they expect to be able to reach us on lots of different channels: email, phone, Messenger, Facebook, Instagram. So there's like, and the sort of, we have to be able to look after them and to be able to deal with this flow of information and communications, and it's difficult. you know Companies now have, full-time people managing, even small companies, full-time people managing, sort of, social media communications and that kind of thing. So, yeah, there are challenges. I think that things move quite fast as well. And of course, the industry is changing, and it's like a number of the sort of companies in our sphere do their own distribution, that kind of thing. I think the best skill you can have is being adaptive, so being capable of change. So we have to feel our way forwards. If something's not working, we've got to be able to change it and work in a different way, and we've got to be able to do this quickly. I think there are challenges ahead in terms of our industry, in terms of expectations on price, that kind of thing. Um, but I think this isn't specific to our industry, it's about all consumer goods. But I'm not, how do I put it? We can only do what we can do. So, for example, we'll engineer the product the best we can. We'll do the support the best we can. We'll listen to as many people as we can, and we'll try and find our way through. There are challenges for us. There are challenges for all sorts of people, the way the world is moving. Um, and I think it's everything from any kind of consumer interaction, from purchasing food to purchasing clothes to purchasing vehicles. The modes and models are shifting rapidly, you know, and I think it'll probably be, yeah, I'm optimistic. I'm an optimist. I think there's a, certainly when it comes to hardware production and engineering, there's a sort of democratization of production going on, which actually means that small companies now do have access to top grade manufacturing through global supply chain. And, that's amazing. We couldn't do this 20 years ago. Couldn't do it. I mean, we couldn't have access to some of the things we've got access to now. This is just fantastic. Our suppliers are based everywhere, and we can pick experts from around the world. It's fantastic. So I'm actually really excited for the future. I You touched on Superbooth. Superbooth is so much fun. It's great. It's this great show, and it's like, you know these things are niche things. The Super 6 is a niche product, and it's a global niche, and things like Superproof bring together these global niches. And somebody was talking to me last night about something that's quite big in Germany, um, LARPing. I don't know if you've heard about it. Live action role play, I think it stands for. um, and it's something I'd never even heard of. And somebody was telling me, oh, they had this huge convention where people from all around the world, like 10,000, 20,000 people turned up to this giant role play, and we built this entire miniature city. And I was like, wow. And the idea that there are niches of special interest groups that are global, but when you take it worldwide, it's actually quite a lot of people. Technology that can bring those people together and make them talk to each other and share information and meet up at places like Berlin and in April this year. Oh, fantastic! I'm a big supporter, and there are challenges for us for sure. And the biggest one is the expectation of being always on, always available for communication across every global time zone is really hard for a small company. Um, but at the same time, the benefits are huge. We can get now. We can well, we can have a global reach. Which is fantastic. It's just fantastic, really is.
We're now in 2020 and are faced with the simultaneity of the non simultaneous more than ever. And for example, the MIDI Association has just announced the full specs for MIDI 2.0 this week. That's supposed to allow for features like automatic setups and self-configuration depending on a device's purpose or type. Machine learning and AI take a giant leap forward with many still speculative outcomes for music making, composing, as well as music distribution and the role of the artist in general. More and more alternative gestural controllers arrive on the market, and the Eurorec scene is still burgeoning with explorations in especially the digital realm. At the same time, the synthesizer seems to have finally reached the status of the electrical guitar, with more and more reissues and clones hitting the market, following the socio-cultural desire for a retro-driven movement that risks being stuck in a loop as opposed to what was once regarded as an opportunity for the future of music. And you once responded to some of this by saying that we've got a problem with our consumption of goods and energy, and that you'd like to think more in terms of sustainability. What does that entail in concrete terms for someone who's designing and developing hardware instruments?
That's that's a very broad question leading up to that. It's good. I think it's insightful what you're saying there, Mike. In fact, I was just having a conversation at lunch with a girl called Aduna who works here at the cafe on the site where we are about clothing. She works for an ethical clothing brand, and she described how I was saying, oh, it's a really good shop. I I don't, I can't shop in there because it's out of my price range because we're still like still not taking a proper salary yet, of course, because we're not out there selling with UDO. But so I said, oh yeah, it's like. But they're very expensive, those clothes you sell. And she almost took a step back and says, well, actually, they're just the correct price that they should be. Because she said that the thing is that with consumption of goods, and I think I agree with her, is that we should perhaps aim to have less things, but perhaps those things that we have are of a kind of greater permanence and a sort of a more lasting or more personalized, more personal quality. And that particularly applies to clothes. But I think it applies to musical instruments itself. So, for example, if you sell something that's um, solely based on, look, this new thing that this one does. Um, Something comes out a month afterwards and goes, this is the new thing that this one does. Um, and you go, oh, that's obviously, oh, this is the new thing that this one does. And you end up in this constant cycle. And it's interesting that you mentioned guitars and electric guitars. You say that the synthesizer has now obtained a par level with electric guitars. I think it hasn't quite personally, but I think it's getting there. And this is something that I thought of from the very beginning of this project with the UDO Super 6, is this parallel between classic guitars. And I believe that a musical instrument, if it sounds nice, if it's really fun and inspiring to play, and it's really well engineered and it's really well made, so it's built to last, it's timeless. It doesn't have it doesn't have an expiry date where it goes, oh well, that's not needed anymore. So I think in terms of instruments and hardware production, you know, there's always going to be a proliferation of new and lower cost instruments. But actually, I think that increasingly people are going to look to their electronic goods and they're going to think a little bit about when they buy electronic goods, a little bit like when they buy clothes. Maybe people aren't thinking that already, but some people certainly are, or certainly when they buy food. I mean, in the last kind of like 20 years, the revolution in people's awareness of food and where food is produced, how it's produced, where it's grown, how your diet affects, the environment you're a part of. That awareness is there. No one even thinks about it for technology at the moment, but actually, e-waste and the kind of ethics of technology production, the rare minerals that are in your phones, etc., are actually an important thing. And I think this awareness that you need to kind of that not all things are equal. If one system has one VCO and one VCF and one VCA, it can be compared like for like with something that has exactly the same features. I think that awareness is growing in the same way that it's growing with a guitar, that something that has like 6 strings and a neck, you know, the other one does too. They're not necessarily exactly the same thing. So I think in the background there is this growing awareness, and I think that's one of the reasons we made um, the Super Six and the way we made it, and the enclosure and the chassis and the hardware and the way it was put together as constructions. Because look, we can't make you the cheapest synthesizer going. We can't do it. But what we can do is we can spend a bit more money on the production of it, because we can make some less instruments so we can access a more niche market, and so that we can improve the paint and the hardware and the chassis and the physical elements and the things that make a musical instrument. We spend a bit more on the components for the sound, etc. And I think it won't be for everyone, but I think there's always a place for a span and a range of things, you know. And so I think the future of hardware production and in a sort of changing world, well, actually, there's been a race for more and more and cheaper and cheaper. But I think at the same time, particularly in synthesizers, it's like rather than get stuck in a repeating loop, I don't think about it so much like that. I think about it more like a refinement of an art form, and like things are actually getting better. Um, you know, analog polysynths from the late 70s and early 80s just sounded great. Some of them sounded really amazing, like really lovely. And then for a long while, the sort of VA synths and some of the sort of modeling type synths and whatever, and DSP synths were a bit sort of, the sound wise didn't have the same weight and they were a bit meh. And so then analog had a bit of a revival, and analog came back, and then there's like new analog and old analog. And so things are still sort of like moving, but these old synths of the 70s and 80s, no velocity, bulky, unreliable, expensive, heavy, generate heat, flaky pots, um, you know, and the new ones have got all these advantages, but now a lot of the sound of the old ones is now getting much better in the new ones, and then it's sort of refining an art form. And I think like the guitar is an art form, the synthesizer, and particularly the analog synthesizer, is an art form as well, and it's a process of refinement. So I think cloning and making a sort of not quite original version is like definitely has its place. Um, Definitely, I think that there's an opportunity also though to capture the magic, capture the nostalgia, and take the art form a bit further. I don't think they need to be exclusive. You can do them both. Um, but yeah, I think certainly. I mean, even now we have to apply to e-waste regulations, so we have to have special bins and stuff for the stuff we generate. And actually, it is a thing. But actually, music technology is much more affordable now than it was when I started producing when I was like 16 or so. And I think that's a really good thing. Really good thing.
What excites you the most about current developments or trends in music technology, be it tied to software or hardware developments or the exploration of new or different concepts? Is there anything in particular you would like to see in the future, or anything where you say, why hasn't anyone done this or that?
I'm really excited by modern expressive controllers and the instruments that they interact with. And I'm quite excited to see the Osmos. And I'm quite excited to see how what we can start doing with a really nice sounding kind of physical modeling in conjunction with these new modern expressive controllers, and how the modern sound communication protocols, things like MIDI 2.0, etc., open sound control, can work with these modern expressive controllers, and to see what we can do with things like FPGAs with their sort of high processing capability, parallel processing, to get really natural, really nice sounding physical modeling type sounds, this area. And I'm really interested to see the development of the analog synthesizer as well. I just think it's a great concept and a great type of thing, and stuff is coming out which is really nice now, really interesting. And I think the Super 6 sits among them. Also, computing and computer technology for basically for recording, and then for doing all your mixing and mastering and sort of processing in the box, as it were, that sits alongside sort of the instruments for performance and expressivity outside the box. Yeah, I'm really looking forward to. I've got a shopping list. When I start, hopefully, um, paying myself a proper wage, I would really like an expressive controller. I'd quite fancy the Harken Continuum, one of those resonator chambers. I also really want a really nice baby grand piano, but I think that might be a little way off yet. Plus, I'd like a vibraphone,
A
and it
vibraphone.
goes on. Yeah, and it goes on and on and on, Mike. But yeah, and yeah, so I think for me, if there's an area which I think's underdeveloped, and is going to get exciting, is it's that area in between expressive controllers, protocols for communication between expressive controllers and instrument processing associated with the modeling and the instruments that they connect to, and that ecosystem. And also for me, I want it to be simple and seamless and integrated, and that's like not quite there yet, I think, with a number of things. So I'm excited.
So ultimately, combining sound design and the means of expression.
Yeah. In kind of integrated instruments that are outside of the computer sphere. That I'm waiting.
That's a good thing to look forward to, and also a very good note to end upon. George, I really would like to thank you for taking your time. It has been an immense pleasure talking to you.
No, thank you, Mike.